Here, I'll open up my presentation. Yeah, is the slide visible?
Yes, it's
Okay, okay. So in this second project, what we'll be dealing with is a control of steering control. So I hope you're familiar with the lateral dynamics, modeling of lateral dynamics. Are you uh, taking a course or have taken a course on vehicle dynamics, uh, where we learn about the modeling of lateral dynamics of the vehicle using bicycle model and all?
Yeah, for us it was already over, like the course on vehicle dynamics.
Okay, okay. When did you take it? Just so that I'll
I think
in
two
second semester.
semesters back.
In second semester we had that.
Okay,
It's been a year maybe. Yes.
okay, okay. No problem. We'll brush up a little. So essentially here we are modeling the steering of a vehicle, and we'll design a controller so that it will respond just like in the previous case. We wanted the braking system to respond in a particular way with respect to certain parameters like maximum peak overshoot, set like race time and so on. So here also we'll first learn how to model the steering system, and then we'll design controllers, proportional controller and the PI, proportional plus integral. Two type of controllers we'll develop so that we'll get the response in a desired way. Okay, so generally a steering controller or the bicycle model is modeled as a system to which the steering input is the delta is called the steering input, and this delta is given as the input, and we get the heading angle in the sense uh, with respect to the present axis, what is the angle my vehicle's velocity, linear velocity is going to be. So if you see in this diagram, yeah, this is the bicycle model, and the all the forces and the velocities are indicated, as you might have already remembered. So I'll just quickly go through a recap of this, modeling it into a state space model, then getting the transfer functions. And once we get the transfer functions, it is the same exercise that we did for the previous project. So here, once we get the transfer function of the brake system, there is a second part to it. So generally when we have the transfer function, we give a step input and get the response, right? So to make it more realistic, we have a second part where we are having steering actuator dynamics. So in the physical case, when we give a sudden step input means from 0 it will jump to a value within no time, theoretically. So here, as the second part of our project, we have what is called steering dynamics. So here, yeah, so steering actuator dynamics are also involved as a second part of this exercise. So if you see the block diagram, uh, are you able to see my cursor?
Yeah, but switch to laser, that will be better.
Okay, okay. I don't think I have a laser option. I'll go with the pointer. So I'll annotate it so that you'll be able to understand. So this is our bicycle model, basic bicycle model, which when given the input of it takes the input as the steering input delta and gives the output of the heading angle. It determines where the angle of at which angle my vehicle is going. So the first exercise is we design the controller without the steering actual dynamics. We design a controller, two controllers. One is the proportional and other is a PI controller for this vehicle dynamic model, bicycle dynamics model, bicycle model. Then we put steering actual dynamics with this given transfer function, and then again design the controller, same P and PI, and then